Hey guys, this is Miss Mo. So now we're on number 20. And 20 just says the derivative. Woohoo! Okay, so the derivative of a naked number goes away. The derivative of a number x is just that number, 5. The derivative of an e to the x still is e to the x. Even if you have a number on it, if you have a number, e to the x, it still pops out a number, e to the x. When we have e to a bunch of stuff up in the air, that's when we have to use the substitution from, what section was that? Like 12.2 or something? So if we just have e to the x, his derivative is the same. Number e to the x, his derivative is the same. E with a bunch of crap in the top, yeah, we got to do something else. But for us, we just have number e to the x, so it spits out number e to the x. So, plus 2e to the x. Huzzah. Okay, let's look at 21. We're still finding the derivative. Oh gosh, I don't remember how to do this. Okay, so 9x squared. Let me work on that first because I remember that one. It makes 2 times 9 is a positive 18. X to the subtract 1 from the air. So just a 1 in the air. And then the 8 goes away. Okay, now we need to find the derivative of that ln. I think it's just 1 over x, but I don't want to get it wrong. 1 second. Oh, where it be? Nope. Oh, I'm wasting time. Oh, this. Okay, goodness. Where is it? Nope. Where's all those? Oh my gosh, it's still videoing. This is ridiculous. It's somewhere. Ugh. Okay, anyway, I'm just gonna say it's 1 over x because it is. Ooh, is this it? No, never mind. I'm just going to say it's 1 over x because I think it is. Okay, so the derivative of this ln x is just 1 over x. But then I have to multiply it with that number in front, negative 10. So let's see what we get. That negative 10 times 1 is negative 10. And then it's all over x plus 18x. And then, hey, that's my derivative. So if you're wondering how I got that negative 10 over x, remember, this is a negative 10 over 1. And then you multiply left to right. So negative 10 times 1, negative 10. 1 times x, x. And hey, that's our derivative. Okay, let's look at the next sucker. The next one says a number to the x. Okay, that's where we write the exact same thing. So if you have a number to the x, you write the exact same thing, and then you multiply it by ln of that number. And I'm going to give you all the formulas on your test, don't worry. Okay, so the same thing is 29 to the x times ln of that number, 29. Hey, that's it. You took the derivative. Okay, let's look at 23. 23 is the product rule because I have 2 things multiplying. If you look, I have this first sucker is 4x to the 3. And the second sucker is x squared minus 5. So let's remember what the rule is. It's, the first times the derivative of the second plus the second times the derivative of the first. Okay, so let's see here. My first is 4x to the 3. The derivative of the second, that's the derivative of the inside. X squared, the 2 comes down in front, so you get 2x to the power of 1. Then the derivative of 5 goes away. Okay, so the derivative of what's inside the parentheses is just 2x. Plus the second, which is x squared minus 5, times the derivative of the first. What's the derivative of the first? We take the 3, bring it down and multiply. You get 12. Subtract 1 from the exponent, squared. Yay! Okay. Then we're just going to kind of clean it up. 4x to the 3 times 2x is 8x to the, add your exponents. 3 plus a pretend 1 makes 4. Okay. Then plus, let's distribute this junk on the right. X squared times 12x squared makes 12x to the, add your exponents. 2 plus 2 is 4. Then negative 5 times 12x squared is negative 60x squared. Okay, combine like terms. These x to the fourths, they have the same but, so add their fronts. 8 plus 12 is 20, but then keep their same but, x to the fourth, minus 60x squared. Hey, that's the derivative. Huzzah! Okay, let's keep going. Let's look at number 24. Well, poop. There's a bunch of stuff in the parentheses with a crazy exponent in the air. So we're going to have to use that chain rule. Uh-oh. What does the chain rule say? It says you keep the same stuff from inside the parentheses, but you minus 1 from the air. Then you multiply by the derivative of that stuff. So let's see here. This negative 2 is just hanging out in front. We're going to keep him at just hanging out in front. Negative 2, parentheses, the same stuff. 2x squared plus 4. Subtract 1 from the exponent. Negative 6 minus 1 is not 5. It's negative 7. Times the derivative of the stuff inside. So the 2 in the air comes down and multiplies, and we get 4x. Oh, and then the derivative of that 4 just goes away. Okay, so let's clean it up. We're just going to multiply the outsides. And we should be good. Oh my gosh, I forgot. The chain rule. Yes, we keep the same stuff in the parentheses. Yes, we subtract 1 from the air. Yes, we multiply by the derivative. But I forgot, you bring the exponent down in front. So this negative 2 we had, we have to multiply it with this negative 6. That's the part I forgot. Okay, so that exponent of negative 6, you have to bring it down in front. So I did. And now it multiplies with that negative 2. And we're going to multiply that 4x. So let's multiply all 3 of these. Negative 2 times negative 6 is 12. Times 48. 12 times 4 is 48x. And then all that stuff in the parentheses with that negative exponent is good to go. Okay, let's go. Ouch. Let's go to 25. We got to use implicit differentiation to, it says use implicit to find y prime and then evaluate y prime at 2, 3. I forgot to say that. At 2, 3. Okay, so this is where we're going to take the derivative of everything, and if we take the derivative of a y, we're going to put a y prime next to it. So let's go. The derivative of this 8x squared, the 2 comes down in front and multiplies. 16x to the 1. Minus, let's see, this 3 comes down in front and multiplies. 3y squared. But then don't forget, you have to put a y prime every time you take the derivative of a y. And then the derivative of 5 goes away. The derivative of 0 goes away, but I still need to put something. So equals 0. Okay, now we're going to get y prime by itself. Well, first, I think I need to move this 16x away. So we're trying to get that y prime alone. And we get negative 3y squared times y prime equals 0 minus 16x. Negative 16x. And then finish it. How can I get y prime by itself if it's multiplying? Well, we divide. Yeah, divide by this negative 3y squared. Divide by this negative 3y squared. And then that should be what my y prime is. The only thing is, I think these double negatives, negative divided by negative, becomes a positive 16x over negative 3y squared. And you don't have to put that positive in front. I just did it. Okay, so the question was to find y prime. We did. Now I'm sorry. Okay, when these double negatives, a negative divided by a negative is a positive, and they both cancel out. Okay, so I was not supposed to put that negative on the bottom. I'm getting tired. Okay, now we're going to evaluate it at 2, 3. So that means I'm going to plug in a 2 for the x and a 3 for the y. Because this 2, 3 is x, y. So let's plug in our numbers. We're going to get 16 times 2 on the top. On the bottom, we have 3 times y. 3 squared? Yeah. So I plugged in 2 for the x because x was 2. 3 for the y because y was 3. And we get 32 over 9 times 3 is 27. 32 over 27, and that does not reduce. Huzzah! Okay, another one. 26, it says x equals f parentheses p equals 6,000 minus 4p squared. Okay, and it says something about find the elasticity. Find the elasticity E of P. Okay, so the formula for elasticity is E of P equals, what is it? Negative, crap, I think it's negative P over F prime. Let me find it. Here it is. Negative P times the derivative over what you got before the derivative. Okay. So my formula is negative P times F prime of P all over F of P. Okay, so what that means is we're going to have a negative P on top already. Negative P on top already. I think this is what most of us forgot on the last test, was there's already a P in the formula. Okay, then it says F prime. Well, the derivative of this sucker is the 6,000 goes away, and this negative 4p squared, the 2 comes down in front and multiplies, and we get negative 8p to the, subtract 1 from the air, so just pretend 1. Okay, all over what I had before I took the derivative. 6,000 minus 4p squared. Okay, let's go ahead and multiply the tops. Negative p times negative 8p is positive 8p over 6,000 minus 4p squared. And then the very last step is we can reduce this. So I think I'm going to reduce the 8, the 6,000, and the 4. I think we can divide all those by 4. So let's go. I'm going to get 2p on top over 6,000, 3,000, 1,500 minus just a regular p squared. And I think on the top, I'm supposed to have a p squared because p times p is p squared. Gosh, okay, one more and then I'm gonna stop making videos. Okay, let's look at 29. It says increasing, decreasing, maximum, and minimum. Okay, so I'll give you a formula sheet, but basically we take the derivative. Let's go. The derivative is 6x minus 12. Okay, good. Then we're going to look on a t-chart. We're going to plug this into y equals 6x minus 12. I think this is a simpler way that I started doing it on like the second set of videos, but I'm going to plug in this derivative of 6x minus 12, and I'm going to look for when there's a number with a 0 across from it. And that number will go on my number line. So let's see here. 6x minus 12, go to my t-chart. Across from the 2, I see a 0. So that means I'm definitely going to have 2. Woohoo. Now I have to figure out whether what's to the left and the right of it has positives or negatives. Well, to the left of this 2 is 1. To the right of this 2 is 3. So let's go back to that same t-chart and look across from the 1 and the 3. That same t-chart across from the 1 is negative 6. So that means where the 1 is, we're going to put negatives. Then across from the 3, we have a regular 6. So I'm going to put positives. Now I'm going to draw my arrows so I can figure out whether it's the max, min, increase, decrease. So these negatives, they go down. Positives go up. So we have our increasing. It's increasing from this 2 all the way to the right to infinity, because this number line has an arrow on the end. So it's increasing from 2 to infinity. It's decreasing from whatever the left side of this number is all the way up to 2. And the left side of this number line is negative infinity, and then all the way up to 2, parentheses. Then it says, what is your maximum or minimum? Well, because we go down and up, it makes kind of a valley. So this is a minimum. And it's a minimum when x is right here in the middle, 2. So I have, we already found our increasing, decreasing. Then we have a minimum at, I'll rewrite it, at 2 something. Okay, to figure out that something, we're going to take this 2 and we're going to plug it into the OG, the original equation. Or you can plug the original equation into y equals and look for a t-chart and look for what's across from a 2. I'll just do it by hand. So I'm going to take this 2 and plug it into the OG. My pen's running out. So we get 3 times 2 squared minus 12 times 2 plus 2. I think we get negative 10. So that's our minimum, 2 negative 10. And again, to get that negative 10, we had to put that in the OG equation, the very top equation. Okay, let's look at 30. It says concave up and concave down. Pretty much the same thing we did, only we got to find the second derivative. So let's do the same thing we just did on the last problem, only we got to find the second derivative and put him in the t-chart. So let's see here. The first derivative is, bring the 3 down in front, multiply, subtract 1 from the exponent, 3x squared, minus, take the 2 and bring it down in front and multiply, 24x to the subtract 1, just 1. Then 11x just becomes 11, and 2 goes away. Okay. Now what we're going to do is we're going to put this in y equals, oh wait, we got to find the second derivative because of concave up and down. If I was doing increasing and decreasing, I would put that first derivative in the y equals like we did on the last problem. But because it says concave up and concave down, I have to find the second derivative. Darn. Let's go. You take that 2 and bring it down in front, and you get 6x. Then the derivative of this negative 24x is just negative 24. Then the derivative of 0 goes away. Now, for concave up and down, we're going to put the second derivative into y equals. And we're going to look for when there's a number with a 0 across from it. So let's put this second derivative in y equals. Go to your t-chart. I see a 4 with a 0 across from it. So that's the number that's going to go on my number line and probably be my inflection point. Okay, now let's find a number left and right, maybe 3 and 5. Okay, now let's find their y values from that same t-chart. 3, negative 6. What was the other one? Oh, 5, 6. So that means on top of the 3, I'm going to put a bunch of negatives because his y value was negative. On top of the 5, I'm going to put a bunch of positives because his y value was positive. Then I'm going to draw my arrows, and it turns out the same as the last example. So that's awesome. And now let's label concave up and down. Concave up is starting at 4 all the way to the right because that's the arrow pointing up. So from 4 all to the right is 4 to infinity. Okay, now the concave down is from 4 and everything on the left. So that means negative infinity, roll up to the 4. Okay, now we just have to find inflection points. Well, there's only an inflection point if your arrows meet going different ways. So because we went down then up, this 4 is an inflection point. So I know this inflection point is at 4 comma something, but I don't know that something. Well, that's a y value. So I'm going to put 4 into the OG equation to get my y value. So my original equation is way up here at the top. X cubed, so 4 cubed minus 12 times 4 squared plus 11 times 4 plus 2. And I'm not going to do that in my head. Let's put this in our calculator. Hey, I got negative 82. So your inflection point is at 4 comma negative 82. Yay. Okay, keep going. Number 31. 31 is a picture. And I think I missed 27 and 38 and 32. Oh my gosh. Okay, let me go back to 27. 27 says, what are the decreasing intervals? Well, remember, decreasing intervals look like they go down. Yeah, okay. So let's find everything that looks like it goes down from left to right. From right there. Then maybe that's also down. Then maybe from F to G. And I think that's it. Everything else goes up. So my decreasing intervals, I describe it using my x values from B all the way to not just C, but to D, because this whole thing is going down. So instead of splitting it up into 2 pieces, we can just say the x value of B to D. Okay, then over here, the x values are from F to G. And hey, there's my decreasing intervals. Okay, let's look at the next picture. I think I skipped number 28. Local minimum If it's a local, as in it's not absolute. If it says absolute minimum, it's a different story. If it says local minimum, it's the bottom of the hump or the top of the hump. And the hump can be pointy. Okay, so minimum is when we have a valley. Maximum is when we have a mountain. So let's find when we have a valley. Right here, because it's the bottom of a valley. Let's see, we have kind of a pointy valley, but the bottom of a hem is E. And then you might think this very left-hand side is a minimum, but when it's a local minimum, it can only come from a valley, like the right and the left-hand piece. So this little yellow piece over here is not a whole valley. It's not a whole dip. It's just you go down, but you don't come up. So to have a minimum, you have to go down and then up. Okay, so our minimum is going to be this point at the very bottom. And this problem just wants you to write down the X value. So C, comma, and then this other bottom of the hump is E. Hey, done with that problem. Okay, now let's go to 32. 32 talks about absolute and absolute. Okay, well, absolute can be a valley or it can be a dot. So I'm just going to say it can be anything. Okay, but on this particular question, actually, I think this is number 31. My bad, number 31. This particular question, it says over the interval 1 to 12. Over the interval 1 to 12. It gave me that in the word problem. So next to the picture over here, way over 1 to 12. So that means I'm only going to look at the piece of the graph from 1 to 12. So where is 1? Right here. Where is 12? Not over here at the 18. 9, 10, 11, 12. So we are only going to look at the portion of the graph from 1 to 12. Just this area. Not this area. Okay, so it says, what's the absolute max? Well, the max is the highest, absolute max is the highest point from this curve. Well, what's the highest part of this curve? Is it this little dot right here? Nah, it's this top hump. So my absolute max is whatever this Y value is. Let me find it. 6. Yeah, okay. So it looks like the very top of this hump is when X is 1, 2, 3, 4, 5, 6 to the right, and then up 1, 2, 3, 4, 5, 6, 6. Okay, and then the way we write it is we say the max is blah, blah, blah at X is, or X equals blah, blah, blah. So we're going to say the max is, and then I put the Y value. So the max is the Y value 6 when X equals the X value 6. This one was kind of tricky. So you're going to choose the answer choice that says the maximum is, and then you type in 6 at X equals 6. Okay, now let's look for the absolute minimum. The absolute does not mean it has to come from a valley. It means it comes from the lowest portion of your graph. Well, the lowest portion of my graph of just 1 to 12 is this point right here at 1, because everything else is higher than it. So the absolute is this right here, and it looks like this point is at 1 to the right, 0 up and down. So that's your X and Y. So now let's put it in a sentence. We're going to say the absolute minimum is the Y value, 0. at x equals the x value, 1. Yay. Okay, done with the pictures. Yay. Okay, let's look at 32. Actually, no, stop.